Well, good morning, viewers. Well, it might be morning, might be afternoon, wherever you are. Today we have a 2010 Jeep Compass, and as you can see, the right headlight doesn't work. Customer had this problem and then changed the headlights to LED with an LED kit, and it's supposed to be plug and play, and it still doesn't work. So he assumed that the bulb was bad, and these are controlled by the TIPM. So we're gonna scan it to see if there's any current codes for the headlight circuits. It also has a problem with the brake warning light on, and somebody apparently has diagnosed it. You can see the brake warning light up here as a faulty fluid level sensors. So I've got one. It was only a few dollars. So let's scan it and see what it has to say. So I've already ID'd the vehicle. So we'll start out with a network scan. $145,000 kilometers, not very many miles. Way fitted systems. And let's do a code scan. Now Chrysler will let you do a network code scan with it running. Invalid skim key. And it might have a remote car starter, but they didn't mention anything about starting issues. Left high beam, left low beam circuit high, stored. Right high beam, right low beam circuit high, active. Well, this is probably him installing the left headlights and having the key on or whatever. And this is the one that I'm worried about right now. Right high beam control circuit active and brake fluid level circuit high active. Oh, that's interesting. And tire pressure sensors, that's it. Alright, well, we're going to clear all the codes and see what comes back. Now, to clear codes on a Chrysler product, as you're going to see, key on, engine off. So we're going to clear all codes and then go back into the totally integrated power module or front control module, whatever they call it today, and see what codes come back in there. And now some of the headlight codes may only come back when you try to activate the headlights, like try to turn on the high beam or the low beam or vice versa. And of course it says it cleared all codes, but that doesn't necessarily mean that they cleared. Central gateway, TIPM. Let's see what come back, if anything. Right high beam control, and let's put the low beam on and see if that. So as soon as I switched to low beam, it created another code. So obviously there's a problem with the circuit. So we're at the right headlight assembly, and I've unplugged the aftermarket LED light, which is supposed to be plug and play and have the appropriate resistor in it to mimic the load of the conventional bulb. First thing I want to do is check pin fit, and it feels pretty good. Now, he installed these when it wasn't working, so I'm going to plug in a conventional light bulb and see if it works. I'm going to hold that. I don't want that to touch anything. Well, I'm going to tie that up with something. This is the original bulb that he had, I believe, from the left side, which was working. Avoid touching the glass part of the bulb because the oil from your fingers will cause it to overheat and possibly blow up. So I've secured this bulb here and I'm going to try it now. So it still doesn't work unless I put a defective bulb in here. I might plug in a new one and try it, but I'm pretty sure that bulb looks good. Filament wise looks good. So we're going to have to investigate the wires at the base of the TIPM. So the conventional bulb works, the one I was trying on the right side does work on the left side. But the interesting thing is the LED bulb sets a fault code. Even though it works, it sets a fault code on that side. So we're going to focus our attention on this wiring circuit for the right side. So here's a portion of the electrical diagram showing the right headlight assembly, and you can see there's a ground at G104, and it comes directly from the integrated power module, right low beam driver, right high beam driver. So let's qualify this ground first and foremost, because that's easy to do. If there's a problem with the ground, it would affect both circuits. Let's qualify that ground. That's pin 3, which is black and pink. So the black and pink wire is the middle wire here, and I've got a headlight connected to the positive battery post, so if I find a ground, the headlight will come on. It should come on when I attach it to this terminal, and it doesn't. So I'm looking for a possible break in this ground wire. That would make sense. Now let's find out where that ground is. Well, G104 is also the ground for the parking light on that side and the right turn signal, and they're all working fine as far as I know. So it has to be a break unless there's a, well, let's find out where G104 is. So I found a ground distribution diagram for G104, and that ground is used by a pile of stuff, and interestingly, it's used by the brake fluid level sensor. So maybe we have a problem with that ground, but it's not affecting the other things. It looks like this ground location, the bolt for instance, might be used by G104 in all these other circuits, but nevertheless, we got to find that. I still haven't found it, believe it or not. So here it shows G101, left side of engine bay, 100 rear of engine, 104 you're on your own, 103 you're on your own. So I resorted to old school inspection, and I think I see it down there, way down there, and I've got the headlight connected. There's a lot of wires going to that ground. Let me zoom in on it. Wow, I can see the black pink wire right on the outside edge, and it looks like it's green. It won't focus. Well, let's take that apart and have a look at it. So I got that ground out, disconnected it, and you can see the black pink wire fell off, this black yellow wire fell off, and the black white wire fell off, and the rest of them aren't far behind because they're all crimped under this one eyelet here. And I took the overflow coolant reservoir bottle out to give myself some more room, so I'm going to extend these wires, each individual wire, because this is very difficult to fix in here and it'll be too short. The factory put a piece of plastic in here so that the wiring harness didn't vibrate and break off. That's what this white plastic piece is in here, just a reinforcement. But we're going to extend all these wires and probably put individual eyelets, because there's like 1, 2, 3, 6 wires in here. 6 or 7. 7 ground wires in that, sharing that. Oh well. So if you solder the terminal, it will seal it to keep the salt from wicking its way up there. And we're going to put a piece of heat shrink over it as well. The other end where we're putting uninsulated butt connectors in, the wires are compromised, and I'm not going to peel back 2 feet of harness here to attach a wire, so I'm using mechanical crimp and heat shrink. So there's all the wires spliced together. I did double up 2 of the smaller grounds. These 2 black ones are going to 2 smaller grounds, but I kept the single heavy grounds individual. I put 5 terminals, 5 wires instead of the 7, and I've sealed it up as best I can, and we're gonna clean up that stud and then bolt it back up and see if everything works now. Well, as you can see, they're working. It'd be really interesting to see if that gets rid of the low brake fluid level sensor code. Well, that's a good sign. All of the codes have switched from active to stored, so let's clear them out and see what happens. I do have a battery charger on it. Look at that. Let's switch it from high beam to low beam. There's high beam. Whoa. That's interesting. I wonder if those LED lights generate a fault, because when I have it on high beam, it sets fault codes for the right low beam and left low beam circuit. If I put it on low beam, that's low beam. Do they switch to stored? No, they don't switch to stored. But that's probably the LED lights that he put in, the aftermarket one, because when I put a conventional bulb in there, it doesn't do that until I switch it to high beam. There's high beam. As soon as I switch it to high beam, it generates a fault code. Now, as long as there's no warning indicators on the dash, we're going to let it go like that. Yeah, those LED lights are generating fault codes, but they're working fine. Yeah, smoke and mirrors. I'm going to plug in the conventional light bulb on one side. Okay, I plugged in a conventional headlight bulb on the left side. Let's clear the codes. Codes erased. Let's go back and read them. So we got the right low beam code because it's still got the LED in it. And I'm going to switch it to well, the conventional bulb doesn't set a code, so I'm sure it's got to do with the LED workaround. As long as they work and it doesn't turn any messages on the dash, we're going to let it go. So that got all the warning lights off except for the TPMS light because it's missing TPMS sensors. But you will notice, if you look at this daytime running lights here, you can see them actually flickering. And that's because the TIPM duty cycles the conventional headlights at about a 60% duty cycle. I'm not sure what the frequency is, but regardless, an LED light will respond to that frequency, and so the lights will be flickering on daytime running light mode. Of course, if you put the headlights on normal, they're on 100%, so they don't flicker. I noticed a weird anomaly there. Well, we'll leave it at that for now. Thanks for watching.